Shalom to you and welcome. In this video, we're going to look at complex numbers and solve quadratic equations that involve complex systems. Before this time, you've been working with real numbers. You started with whole number in the first grade, and then by early or late elementary school or middle school, you learn integers and then rational numbers, and eventually real numbers. So at this level, we are going to bring in imaginary numbers. So complex world is made up of imaginary numbers. Imaginary, you can't see it, but they are there. We can imagine it. And then real numbers. They're not real numbers. We see them, we can touch them, we can count them, but imaginary numbers, we can't. So I is a symbol that is used to represent imaginary numbers. So we're going to add, subtract, divide, multiply imaginary numbers, and then solve quadratic equation involving them. We're also going to use discriminant to determine the character of solutions of quadratic equation when there is no solution, no real solutions, two real solutions, or imaginary solutions. So now, complex number, there are numbers written in this form. You have like a plus bi. A and b represent numbers. They are not numbers. It can be any rational number. So the part that is just number is the real part. We call it the real part. And then the part that is combined with imaginary I is called the imaginary number. B is the imaginary part and I is the imaginary unit. Now, I squared equals -1, and we'll see why. So because -1 is equivalent to I. So before now, whenever we solve an equation we say that you cannot have a negative number under the square root. So, but after this lesson now, we'll be able to simplify it, because all it means is that negative number will turn to imaginary number. So if we square both sides of this equation, and then this will cross out, that's how we get I squared equals -1. So if you have any number at all, a negative number under the radicand, we can just take out the I, because we can make that number be the square root of -1 times the square root of that one. The square root of -1 is I, and then if we multiply it by the square root of r, that leaves that alone, then we can evaluate it. Okay, now other things we need to know for this lesson is the conjugate. The imaginary conjugate, the conjugate is symbolized by putting a bar under the whatever you want the conjugate of. So if it is z, then the conjugate of z, just because math uses symbol a lot, so that's what that symbol means on top of it. So, and the conjugate simply means if it is positive, make it negative. So the conjugate of a plus bi equals a minus bi. So a plus bi and a minus bi are conjugate of each other. So another thing we need to remember, conjugate is very useful when we divide by a complex number. That is, if the complex number is the divisor, is the complex number, we have to divide by or multiply the top and bottom by its conjugate before we can evaluate it. Okay, let's look at an example. So look at this. It's one of the problems in the textbook. So 2 minus I divided by -2i. So we see the divisor is an imaginary number. Therefore, before we can divide it, we have to multiply by the conjugate of -2i. And the conjugate of -2i is +2i. So it's +2i divided by +2i. when you divide a number by itself, it is equal to 1. Therefore, multiplying by 1 does not change any expression. Okay, so, but it helps us evaluate that or simplify it. So we can distribute this 2 times 2i, it's 4i, negative I times 2i, it's negative 2i squared, over, then negative 2i times negative I is negative 4i squared. Okay, so we can simplify this because we have 4i negative 2. Now negative I squared is, I squared is negative 1. Okay, like we reminded here. And then over negative 4 times again I squared is negative 1. Therefore, this comes to 4i, then negative 2 times negative 1, that would be plus 2, over, then negative 4 times 1 is positive 4. And now we can separate these. We can separate them to 4i over 4 plus 2 over 4. So 4i over 4, that will be 4 divided by 4 is 1. So that left us with I plus 2 divided by 4 is 1/2. Or we can write it as 1/2 plus I. That way, by commutative property of addition, we can switch those. Okay, so we can do more here. We can FOIL. So 3 times that is 12. We have the square root, so we have 12i. So 4 times negative, that is negative 16. And then we have this, or rather I will do it this way. So that's 3 times 3 is 9, positive 9i squared. And then that will be negative 12i. All under square root. And then we can collect like terms. So we have 12i and negative 12i. Positive and negative cancel each other. So we have 16 plus 9. But then I squared is negative 1. So that is 16. Then 9 times negative 1 is negative 9. And that gives us, I'll bring it up here. So negative 16 minus 9 is negative 25. Oh, so I realized I dropped the negative here. Oh, this is negative 16 because we have that here. So it's negative 25. Okay, so if we remember that this is going to be square root of negative 1 times square root of 25, it will still give us square root of negative 25. So negative 20i is square root of negative 1 is I, and then times square root of 25 is 5. So this comes to 5i. Okay, so this one we are subtracting. So we just need to distribute that subtraction, keep the first number, distribute the negative one, negative. So that will become positive 2i, and then collect like terms. So the negative 8 and negative, that is negative 10. 4i plus 2i is plus 6i. And that's it. Okay, this one is multiplication, so we FOIL. So 3 times negative 3 is negative 9. And negative 3 times I is negative 3i. And I times 3 is positive 3i. And I times I is positive I squared. So collect like times negative I and positive I cancels out. And then I squared is negative 1. So we have negative 9 plus negative 1. So that gives negative 10. So now solving the quadratic, you can use any method you want. But here, if you try to factor, you can't find a number because it's going to come to imaginary number. So the easiest one to use will be quadratic equation. I mean the quadratic formula. So our A is 1, our B is negative 1, and our C is 1 because it's already set up equal to 0. Then if we do B, okay, let me just write the whole equation here. X equals negative B plus or minus square root of B squared minus 4AC all over 2A. So X is negative and our B here is negative. So we want to put that into parentheses. Okay, B squared is negative 1 again, squared minus 4 times. Our A is 1 and our B is, our C is also 1. All over 2A, 2 times 1. Okay, X equals negative is positive B plus or minus square root of 1 squared, or negative 1 squared is 1, minus 4 times 1 is 4 over 2 times 1 is 2. So this is B plus or minus square root of negative 3 over 2. Oops. So, oh my gosh, okay, we're supposed to replace the B here though. What is B is negative 1. It's negative 1. It's negative 1. So negative is positive 1. So we have the square root of 3 is going to be 3i, right? So X equals 1 plus or minus square root of 3i. Okay, because the negative 1 is going to be I. So 3 is not a perfect square, so leave it like that. And over 2. So we can separate that X equals 1 plus square root of 3i, and X equals 1 minus square root of 3i, over 2. And sometimes they write it as separate because there are two terms here, 1/2 plus, so I'm going to write it as a set of 1/2 plus square root of 3/2 I and 1/2 minus square root of 3/2 I. Okay, so it's good to kind of familiarize yourself with multiple ways of writing it, so whichever way it's presented, you don't get confused. Okay, another one from the book. We do the same thing, use quadratic. A is 10, B is 6, C is 1. So the quadratic. X equals negative B plus or minus square root of B squared minus 4AC all over 2A. So X equals negative, B is 6 plus or minus square root of 6 squared minus 4 times A is 10 and C is 1 all over 2 times 10. So x equals negative 6 plus or minus square root of 36 minus 4 times 10 is 40 times 1 is 40 over 2 times 10 is 20. X equals negative 6 plus or minus. Okay, 36 minus 40 is negative 4 all over 20. Now, we know 4 is a perfect square, so which is 2. So it's going to be 2i. Hope you get that now. So x equals negative 6 plus or minus 2i over 20. Okay, let's separate them. X equals negative 6 over 20 plus 2 over 20i, or negative 6 over 20 minus 2 over 20i, or 2i over 20. So we can actually simplify, reduce the fractions. So x is going to be the set of, because 2 can go into both. So we have negative 3 over 10 plus 1/10 I. Again, be careful, do not write I in the denominator. You rather write it on top. You can write it as I over 10. That would be fine also. So it's negative 3 over 10 minus 1 over 10 I. Okay, that's that. Okay, how about this one? Again, at any time you can pause the video and try to solve the problem yourself first, and then check back with what I did. All right, so we can move, subtract 63 from both sides. So x squared equals negative 63, and x is going to be plus or minus the square root of negative 63. And again, we see it's going to be imaginary number, because 6 is so plus or minus the I times square root of 63. Well, is there any perfect square that goes into 63? Yeah, 9 times 7. 9 times 7 is 63. So we can write this as plus or minus 3 square root of 7i. So separate them. X is equal to 3 square root of 7i, or 3, or rather negative 3 square root of 7, square root of 7i. Okay, now remember that the I is not inside parentheses, so all right. Now, powers of imaginary numbers. So there's a special pattern that helps us simplify them very fast. So if we look here, anything to the power 0 is 1, so we already know that. Anything to the power 1 is itself, so I to the power 1 is I. And you can look at the pattern, anything that is kind of, this part may be difficult to memorize. If you're good at memorizing numbers, you can go ahead and do that, but I don't. So just look for pattern. So I squared, we already know, is negative 1. And so I to the third power is going to be the same thing as I squared times I to the 1. Because when you multiply two powers of the same base, you can add their exponents. So these two will be equivalent to I to the third power. And we already know what I squared is. I squared is negative 1. And then I to the power 1 is 1. I. So I times negative 1 becomes negative I. So that's how this come about. So if you're able to memorize these four, then you will be able to solve any power of imaginary number, because you just use the multiples of 4. If you see, when it comes to 4 to the power of 4, it comes back to 1. 8, 12, any multiples of 4 will give you 1. So if you remember that, I will just convert everything to the, make the exponent be multiple of 4, and then use it to simplify it. Okay, now here, this is just kind of technical in terms of expression. Sometimes you're giving this in an expression, you don't have no idea what that means. So it just simply means the same thing we just talked about. Okay, but again, just concentrate on the multiples of 4. So let's do a few. I to the power of 14. Okay, we think of a multiple of 4 that is closest to 14. So I would do 14 divided by 4. That will give me 3. 3 remainder what? So this is going to be I to the power. Okay, it gives me 3 times, but 3 times 4 is 12. So it's going to be to the power 12 times I to the power. Remainder what? So 14 minus 12 is 2. So these two expression will be equal to I to the power 14. So I know that I to the power 12 will be 1, because any multiple of 4 power is 1. And then I to the power I square is -1. So 1 times -1 is -1. So I know this expression will give me -1. So we can do the same thing here. So find the multiple of 4. That will be I to the power 40 is a multiple of 4 times I to the power 1. Remember 1. So I to the power 40 is 1 times I to the power 1. Anything to the power 1 is itself. It's I. Therefore, I times 1 is I. So that expression will equal I. So 48 is the multiple of 4 already, so it's going to be simply 1. 55 divided by 4, we get 13. So 13 times 4 is 52. So 52 is the multiple of 4. So this is going to be I to the power 52. 52. And what is remaining? So of 55, it's going to be 3. Okay, so we already know that I3 is the same thing as, if we don't remember what I3 is, we can write it as I2 times I1. That as long as the exponents add up to the 55, that will be 5. So 52, 53, 54, 55. So it's easy to remember the power. Okay, so here we have 1, the multiple of 4, and then I squared is -1, and I to the power 1 is I. So we have 1 times -1 is -1. -1 times I, it's -I. And that's our final answer. So we do the same thing for 61. 61 divided by 4 is 15. 15 times 4 is 60. So 60 is a multiple of 4. So 60 times 1 is left. So that gives us 1 times I to the power 1 is 1. So which gives us I. Alright, so you can only get these 4 answers. 1 and -1, I and -I. That's all. Okay, so you can simplify again. This is simply I times square root of 16, and 16 is a perfect square, which is 4, so it's simply 4I. 18 is not a perfect square, but this is going to be -1 times, or rather let me just put -1 at the end to make it look nicer. So it's 9 times 2 is 18 times negative 1. That gives negative 18. So 9 is a perfect square. So that brings out 3. And 2 is not a perfect square. So leave it under square root. And negative 1 is I. Alright. So here we have 3i times 2i. Because 9 is a perfect square, 4 is a perfect square, and the negative 1 is I. So 3 times 2 is 6. I times I is I squared. So that becomes 6 times negative 1. That's negative 6. Alrighty. Now, one thing we can find the character of, determine the character of solutions of quadratic using the discriminant. This problem is from ACT. So you look at this problem, you're asked to solve this quadratic equation and determine the solution from here. And they ask us to find which of the following will be more than, will give us more than one real number. More than one real number. So discriminant, this is testing your knowledge of the discriminant, period. You see, they won't give you a number to solve, they'll give you letters. So, but you need to look for pattern. You look at the quadratic equation, so how do you solve it? Okay, so we will look at that later. Let's understand what the discriminant is first of all. We come back to it. So the discriminant of a quadratic equation or function, it determines when there is two real solutions, when there are two real solutions. Real solution means if the graph of that function crosses the x-axis. So the x-axis is the real axis. The y-axis is the imaginary. Okay, it is the imaginary, the bi. Okay, so that's the x-axis is the real number. So if it crosses the x-axis, then it is real. If it touches the x-axis only once, then it has one solution, but that solution is used twice. It's repeated because based on the fundamental theorem of algebra, quadratic must have two solutions. If it does have solution, there must be two. So therefore, if you solve it and get only one number, it means that number is repeated. So it's itself twice. So that's when it touches the x-axis only once. So the number is on top of each other. So if it does not cross the x-axis at all, then it is imaginary. So it is hanging up or below the x-axis. That's when it is imaginary number. So this is from graph. Now, how do you determine it algebraically? So the discriminant help us determine that, and the discriminant is the number under the square root. Do not include the square root. This does not include the square root. People make that mistake a lot and take the square root of b squared minus 4ac. No, it is only the number under, or the expression under the square root without including the square root itself. That is the discriminant. So if the discriminant is positive, so if you simplify the expression, again, this expression represents the discriminant. If you simplify it and it gives you a positive number, then it means there are two real solutions, real solutions. Now, the discriminant is greater than 0 means it's positive. So many ways of expressing it, and it means the graph crosses the y-axis exactly two places. So if the discriminant is 0, it means that's when there is exactly one solution. Okay, one real solution, and that it means that one number is repeated. So that's when you simplify the expression under the square root and it gives you 0, and that means the graph touches the x-line just once. If the discriminant is less than 0, that means it is negative, then there is no real solutions. But if there's no real solution, I mean there are imaginary solutions, and the imaginary solutions must always come in conjugate pairs. So a number and its in conjugate, and a complex number and its conjugate. And again, the graph is not touching the x-axis. So that's how you determine it. This is again expressing it in a equation form. The discriminant, D representing the discriminant. Note that A, B, C, you know what they represent in the quadratic formula. So the same thing, okay, when it's positive. Now, when there are two real solutions, that's when the discriminant is greater than 0. If that discriminant is a perfect square, it means those two real numbers, real zeros, are rational zeros. So they are not square root unless they are perfect squares. They are perfect squares which can be simplified to numbers. Okay, so again, just a recap of what imaginary number. Complex number is made up of imaginary numbers and real numbers. And apart from the imaginary number, every other thing belongs to real numbers. So let's use discriminant to determine if a quadratic is 0, non-zero, how many solutions it have, or if it has real solution or no solution or no real solution. So we just need to write our A. Our A is here is 1. Our B is 2. Our C is -12. So our discriminant is B squared minus 4AC. So B is 2 squared minus 4 times A, which is 1, times -12. So 2 squared is 4. Then 4 times 1 is 4. 4 times 12 is -48. So it becomes 4 plus 48, which is 52. Now, the discriminant is positive. If it is positive, so since the discriminant is greater than 0, that means it's positive. That means there are two real solutions. Different solutions. Now, 52 is not a perfect square, so it is just real solutions. It could be square root, it could be rational. It could be rational or irrational. So it is irrational. So, but if it is perfect square, then it is sure to be rational. So another one. So we do the same thing. A is 4, B is 3. Again, make sure the equation is solved for is set equal to 0. So in this case it is. So discriminant is B squared minus 4AC. So this B is 3 squared minus 4 times A, which is 4, times C, which is -1. So 3 times 3 is 9. 4 times 4 is 16. 16 times 1 is -16. So that's 9 plus 16. 9 plus 16 is 25. So discriminant is positive. Again, there are two real solutions. Two real solutions. So, but 25 is a perfect square. So they are not just two real solutions, they are actually two rational solutions. So those real solutions are rational. Rational means we can write them as fractions or whole numbers, or so they are anything within the family of rational numbers. Okay, two distinct. Okay, how about this one? A is 3, set equal to 0, B is -3, and C is 4. So discriminant equals B squared minus 4AC. So B is -3 squared minus 4, A is 3, C is 4. So negative, that's 9 minus 4 times, that is 12 times 4 is 48. So 9 minus 48 is negative 39. So the discriminant is less than 0. If the discriminant is less than 0, then there are no real solutions. No real solutions. No real solutions. But there are imaginary solutions. So there are complex solutions. Two complex solutions, because two complex always comes in conjugate pairs. So it must be two complex solutions. Okay, so, and there are two complex solutions that are conjugate pair. It's good to know that they are conjugate of each other. Alright, last one. Let's finish that. A equals 4, B is 12, C is 9. So discriminant is B squared minus 4AC. So B squared is 12 squared minus 4 times 4 times 9. Sorry, that's 9. Alright, clean that up a little bit. Alright, 12 times 12 is 144. Minus 4 times 4 is 16 times 9 is 144. 144 minus 144 equals 0. Discriminant is 0. That means there is one real solution. One real, or rather, one real solution that are repeated. I'll just write one repeated real solution. One repeated real solution. Okay, that means the discriminant equals 0. Alright, let's look at that ACT problem. So we can see what the discriminant look like. It's B squared. Okay, let me write this in color. So discriminant is B squared minus 4AC. Now if you look at these expressions, they look similar to it. So if the discriminant is, for it to have two real solutions, but it says it has to have more than one, so it has to have two real solutions, then it has to be greater than 0. So with that, we can cross out these options. These are all less than zeros. So our expression, it has to be either the first one or the second one. So if you don't simplify this, you would think, oh, it's this one because it looks like that. But what does each of these variables represent? And probably it might be this one, I don't know. So let's work it out. First of all, solve this system of equations. Substitute y is already solved for. So I will take x squared and substitute it into the second equation. And that will give us rx plus s. Then substitute for y. So replace y with x squared. So x squared equals t. So we can write it in standard form, and then since it's quadratic, move everything on one side. So let's write the one that has x squared first, so we can see what our x be, followed by the one that has x in it, because x is the variable. They told us that r, s, t, they are integers, so they are actually numbers. They represent the ABC. And then move t to this side, it becomes negative t equals 0. Okay, so now it looks like quadratic with x squared and x. So we know s is our a. So we write them out. So a equals s, b equals r, c equals negative t. Okay, so we can substitute it into our discriminant. So the discriminant, b squared minus 4ac has to be greater than 0. So if we write this inequality, that's what will give us real solution, two real solutions. So we're going to substitute and simplify. So our b is r squared minus 4 times a is s, times c is negative t. It has to be greater than 0. So r squared, well, if you see here we had negative times negative here, that will make it positive. 4st is greater than 0. So this is simplified, and we can see what we have here is the first one, and that's our answer. All right, hope you got this. A lot to learn. Good luck.